Hello, this is Uma Maheshwar from cybersecurity team, um, from team cyber deciders. So let me share my screen. So our project name is Honeypot deployment. Um, when coming to the introduction, in this present digital environment, the issue of network security becomes the priority that organizers of all sizes that must handle in advance. The threats, including malware, ransomware, inside attacks, and increasing sophisticated, advanced, persistent threats, and continuously deploying defensive measures is even more vital for efficient identification and mitigation. So firewalls, IDS, and antivirus software, and also so designed to serve as the first line of defense against system vulnerabilities that have been proven to fail in protecting systems comprehensively. To meet the ongoing security demands, companies are shifting to honeypots as a precautionary solution to the network. In the risk mitigation field, the honeypots present a novel strategy of trapping and catching fraudulent activities before they can penetrate protected systems. Honeypots can never totally prevent risk, but they can significantly increase a company's safety and protect valuable assets by strategic deployment. The essence of the honeypots is in their nature as descriptive system which intimate the real scene of the computer environments, complete with dictionaries and drives. But we have a solo purpose to fake attackers into the thinking that they have successfully taken the control of the target. On the contrary, these decisions are driven on to a regulated environment where their action can be sanctioned, evaluated, and impeded. Using honeypots in network security requires techniques and tactics specially modified to make potential threats fail. What honeypots do is to serve as a barrier between production systems facing hardened threats and external dangers, so they can be stopped before they get into target. This practical approach has significantly driven the understanding of malicious actors and their methods, patterns, and designs, which security professionals utilize to identify current and deploying threats and apply required prevention measures. Usually, a honeypot we can also use with IDS, intrusion detection system. So, intrusion detection system functions as a core element of security network. Already we know, and surveillance is one among its key functions. By using this equipment, the network security specialists can detect and foil possibility threats before they attack. In addition, honeypots lend extra layers of security to be used in conjunction with IDS, which protect against suspicious behavior. Through the use of honeypots in a network environment, organizations are able to interact with the intruders in a proactive manner so that the possible attackers are lured and received. The useful information to an organization about patterns and way employed by the hackers. The joint use of honeypots along with ideas output a major comprehensive threat detection capability than what any one system can do by itself. Upon recognizing ideas damage traffic, the networks can be assigned to honeypot sites for comprehensive research, which will be used to respond to potential threats. The collaborative way these devices are deployed allows the detection precision of ideas to blend in which the dispersion tendency of the honeypots, thus building a robust defense in dealing with a large number of cyber threats. And coming to the implementation of our project, to improve the efficiency of the honeypot deployment process, This can be addressed by including logging timestamp and customizable uh, descriptive responses. Everything will be done. Um, Firstly, by writing the time of interaction into a log, security analysis, we will have a clear temporal context of each interaction, enabling them with a precise sequence of events, and thereby research of patterns of malicious behavior. Timestamped with logs, we have created a log file after we receive an output from the test Python file. So, and it can be helpful in reconstructing the timelines of an attacker as well as investigating the events that led to an incident. This temporal granularity also gives a chance of real-time monitoring and alerting put in the hands of security teams to wipe off threats, potential breaches sooner. And we can also block the IP address of the hacker by these logs. Timestamp are also key documents for regulatory and compliance purposes. It provides the required proof that the organizations are making ethical and responsible use of security technologies. The honeypot gets effective as its fake customizable responses are designed to increase the deceitful quality, thus attacking and capturing malicious actors. The honeypot channels a different set of fake responses, copying the non-malicious answers variation as well as those of the malicious action of error messages. The complexity of varying reactions, the attacker will find it difficult to determine the real and artificial targets. On top of that, the honeypot system can select random fake responses. Therefore, it is able to show a dynamic behavior, making it more classed as an authentic system. Conversely, this allows criminals to spend more time in the honeypot, hence generating more information about the attacker's tactics, techniques, and procedures. Ultimately, the logging timestampers convey a realistic sense of level together with a combination of customizable fake responses, which adds up to the active function of the honeypot as a proactive defense mechanism, essentially amplifying overall network security and sustainability against cyber threats. About the incorporation of login timestamp into the honeypot deployment, we should begin with importing the time Python module. Here, import datetime and module in Python. In this module, you can find time of uh, function for obtaining the current time in seconds, for converting the timestamp into a readable format, text format for humans within the code. You can then include the functions to log the timestamp along with each interaction or event. Inserting timestamp in the log file allows you to relate the sequence of events to other security logs or events by offering invaluable text. This increases the accuracy of threat analysis and incident response by supplying the right timing information. For customizable fake responses, it is possible to define predefined and fake responses or messages. Here we go. Here are the fake responses we have created. It will be generated by the honeypot when the attacker when the attacker try to connect to the host and port. Uh, it is created in a list. Maybe it will be shown in the output when the attacker connected to the port and host. Python's variability ensures that these honeypot features can be easily integrated into deployment process, taking advantage of libraries such as time and random. Um, Along with the native Python's data structures, one can easily implement the logging timestamps and customizable fake responses in their honeypot code base. In addition to that, the enhancement improve the honeypot system in capturing and analyzing malicious activity. Furthermore, the security analyst work is even more optimized as Python's powerful analysis. Capabilities that are enabled by Pandas and NumPy libraries facilitate the processing and analysis of the obtained data. To pinpointing the patterns and the abnormalities that signify the behavior of a mechanic actor, these tools can be make it possible to be proactive in threat detection and response. Further enhancement of security effort is achieved with the integration of such machine learning frameworks as CTLearn or TensorFlow through the creation of predictive models as a threat detection mechanism. Uh, and sharing information, joining up, strengthening, and sharing information across different deployments. HoneyNet is possible with the socket communication library that is in Python. This can be a stronger defense strategy that organizers can use to make potential cyber threats not evolve. So I'm gonna show the implementation of our project. So we have two Python files. One is for the honeypot to listen the port and the host host network. So let me run this file. So the honeypot is listening to the host and port. So when the while listening to the host and port, when an attacker tries to connect to this port and host, it will listen. It will generate fake responses to the attacker. Let me show you. See, we are getting invalid credentials to the hacker point of view, even though it is connected to the even it is connected from its the hacker IP address and the port. So when I run again, when the hacker tries again, it will get another response, which is a fake response. We already generated we already defined in the list as fake responses, and even though it is connected to the even it is connected from the IP address and another port, we are getting fake response. Welcome to our secure server. So when I run multiple times, we get all our fake responses. So by this, even there is a vulnerability in the server when the attacker tries to connect to the server by using the vulnerability. By using honeypot, we can know we can know the modification he has to do connect the server, and the modification is the attacker done will be generated. So let me close this. So we will get the final output, the IP address and the ports in a log file. So you can uh, you can block the IP address by knowing the which timestamp the attacker is attacked. So let me close this file. Let me refresh. So here you can see the log file generated. Here it is the timestamp with the connection name, address of the IP address of the attacker, and the port he has used uh, to connect to the server. So that's all from our side. Thank you.